Hello, everyone. Sorry about that. Had my microphone muted from the top. All right. Sounds like audio's okay. Just scoot in here. Turn that background down a little bit. All right. Happy Monday. Happy Martin Luther King Jr. Day. So we'll do a normal sort of 2-hour live stream here. I will switch over real quick to the lesson plan view so we can talk about what all we're looking to cover today. Right, so do my kind of intro script here, make sure I don't miss anything. Um, so hi, welcome. I'm Jules. I am a real life CFI, but these are meant to be sort of overview lessons of just a bunch of key topics, the things that you would cover as you're working towards your private pilot license. So we're starting at the beginning, a couple of lessons ago, assuming you've never flown before, and then working all the way through the requirements to pass your private pilot test. I do want to put the disclaimer that although I will be teaching the lesson plans as though it was with a real student, the best way to learn, and really the only way to learn to fly, is to work with a CFI one-on-one who will be able to identify areas you need to improve on, give you feedback, maybe accelerate you through different parts of the lessons that you're grasping really quickly. Another thing that becomes really apparent with a lesson like today is because we're sort of starting right on the tarmac and hopping out to go fly, we're skipping over the pre-flight things like walking out to the airplane and inspecting everything, checking the weather, running through the I'm safe checklist, these sorts of key safety aspects that we think about when we go out to fly in the real world. Every lesson I think about, maybe we should go and do all those things. Perhaps as we get more into the cross countries, we'll start to do that as kind of the like almost sitting, starting at just a table. But for the sake of time, to try and keep these lessons a little more condensed, where normally this would be probably a 3-hour time block that we would schedule for this lesson, I'm trying to keep it still to 2 hours. So we're kind of breezing over those things. Anyway, all of that to say that if you are interested in learning to fly in the real world, and I hope you are, the best thing to do is to go to your local airport and either find a CFI there or find a flight school or a flying club and do a demo flight. And CFI will take you up and just show you how to fly the airplane, let you get on the controls, and actually see if you enjoy it or not. That's how I started my flying career. That's how most of the people I know started their flying career. It's a great way to just kind of see if you enjoy the real activity. I mentioned that I'm working through these lessons as though it were for the full private pilot airman certification standards, the FAA criteria. The lessons do then build on one another, but I'll try and go through, in the way I teach it, I'll try and make it so each lesson is still useful in isolation. So if you're just tuning in for a random lesson here and there, hopefully you pick up some things that make your sim flying better, or maybe your real world flying if you're a student or already a pilot. The videos on YouTube, or I'm sorry, on Twitch from the beginning of this stream are getting to the point of expiring now on Twitch. So if you want to see some of the older videos, you have to go look on YouTube. And I can post that in the chat now. Happy MLK Day, Shoots. How you doing? Okay, so there's the YouTube link. And also, if you have any questions that come up, either if you have questions that come up now, the chat is a great place to post them in. But if you have any questions after the fact, the Discord is the best way to get feedback or questions, to give feedback or to ask questions. I think that is it. We're getting a little bit more stable, I think, with the internet connection, the setup, the audio, the everything. So hopefully it's a little more streamlined today. But as always, if you run into anything on your side, um, audio's cutting out or video's bad or something like that, definitely give me a heads up and I will see what I can do about it. All right, let's dive in then. So today we're working on ground reference maneuvers. This is a particularly important topic because when we think about flying, especially the traffic pattern, where we're going to want to do this consistent pattern that we fly every time when we go to land, um, that's one of the ground reference maneuvers builds on that sort of muscle. So the how do you enter the traffic pattern. The other ground reference maneuvers are all about understanding the airplane moving through the wind and how wind impacts the angles and directions that we fly at. So a little bit of a teaser. We'll dive into a lot more of that, obviously, as we go here. So the objective for today is develop risk management and skills associated with ground reference maneuvers. A little typo in there. Ground reference maneuvers, including rectangular patterns, S-turns, and turns around a point. A couple of useful references here: the Pilot ACS section 5B and Airman Flying Handbook chapter 7. I had turned this into there's something that is off about these. Oh no. Okay, let me see if I can quickly resolve this. So this is using my notes from before I prepped for the lesson, which would be sort of unfortunate because I went through and tried to improve a bunch of these. So let me see if I at least have the maneuvers. Okay, so the maneuvers are all in here. I was worried about that. So something happened with the way that because I do most of my work on my Mac, and then I back it up to GitHub and then pull it down onto the Windows computer. And in that transition, something happened with this specific file. And unfortunately, the way that I have my computer set up, it's not super quick for me to go and fix that. What is the best way to do this? Give me just one moment here, and I'm going to just pull this down bluntly and copy and paste the actual text in. Should only take a moment. If you haven't used GitHub before, I think it's wonderful and highly recommend it for lots of different use cases, but this one is a particularly good one. Okay, yeah, so as I suspected. So essentially what happened was, because I had one copy on this machine and one copy on my um, Mac, when I pulled onto this machine, something about the timestamp or updates essentially said, oh, wait a minute, you meant to use the one that you had on the PC. You don't want the one that you have on your Mac, which is unfortunate. So, okay, here we go. That is one file, and okay. That's okay. So I will pull this one, view this point in history. Okay, great. And we are in good shape. So essentially, because everything is backed up, every time I uh, save that file, I have a new copy of it. So these should all work okay. Oops, except I went to the wrong one. Sorry about that. Okay, view file. Okay, here we go. And raw. Great. Okay, so this should work. So you can see my back-end code in here a little bit. Okay, great. So the thing that tipped me off was I turned these into bullet points as I go through. So sorry about that. Get pull, get fetch plus CI now. Always have a plan B as a backup strategy, just like in flying. That's right, shoots. That's right. You want to have plan A, plan B, plan C, and plan D as all useful. Yeah. Yeah, it turns out the live streaming and flying have a little bit of that in common sometimes. So, all right, we're good to go. So, objective, same thing we talked about. A couple of references here. The Airman Flying Handbook, Chapter 7 is all about ground reference maneuvers. Definitely check that out. And the Private Pilot ACS, that's that Airman Certification Standard. So, this is the section that talks about all these maneuvers. Builds on the 4 fundamentals of flight. So, you'll notice this is lesson 7, and it really builds on lesson 2. Of course, we pull from everything that we've learned throughout the other lessons, but in this case, really what we're going to be doing is a lot of that straight and level flight, turns, and then starting to add in wind correction and what that means. So we could have, in theory, jumped from lesson 2 right to ground reference maneuvers if we wanted. I've actually seen some syllabus that do that, but I prefer to teach some of the intermediaries. If we were out flying in the real world, of course, we've covered takeoffs, covered crosswind takeoffs. We started to talk about some of these wind things. And so when we go out to fly today, the student would be doing the takeoff and would get us out of the local area. So that's part of the reason to build in this area, or to build in this order of lessons. Schedule for today. So I have us for an hour of ground, an hour and a half of flight. I am very cautiously optimistic that we can finish in 2 hours. We're going to try and go to a nearby practice area to actually do these maneuvers. And because we won't be doing this sort of demonstration performance method of teaching where it's, the CFI would explain something, then demonstrate it, and then the student would perform that with guidance from the CFI and then work on it, that kind of back and forth. Because I'll just kind of demonstrate them once through and talk about them, we might be able to get done in 2 hours. This would be a lesson that is more likely than others to go over time. CFI equipment, so this is more a note for myself. I will use a little bit of the tracking on the iPad today. I think that'll be a really useful tool to see. And I'll do some live pauses. Of course, if we were out flying in the real world, we would finish flying and then come back and debrief. We wouldn't look at it in the plane in the same way, but since we can active pause, we can actually talk about it at the moment. All right, if there aren't any questions, I'll dive right into the lesson elements. So there's 4 main things we're going to cover. Of course, the last one is always common errors. Make sure that you're aware of things to be careful of. The other 3 aspects, the effect of wind during ground reference maneuvers. Our dog is pretty excited today. I'm not exactly sure what it is. We've had a theory that it's weather related because our pressure systems have been all weird, and yeah, but anyway. I should mention that my wife and dog are all here from MLK Day, so it's sort of business as usual around the house, I suppose. Anyway, okay, so a couple lesson elements: effective wind during ground reference maneuvers, using maneuvering speed. We'll introduce that concept a little bit. How to actually fly the maneuvers, and then some common errors. So let's dive in here. So first thing to talk about is the effect of wind on these ground reference maneuvers. Background noise is very subtle, not distracting. Great. Okay, shoots. Glad to hear that. Yeah, we have, I have the NVIDIA broadcast background noise filter on, and it seems to work really pretty well. But yeah, the dog was in the other room when he saw someone out the window, I think is what was going on. Okay, so let's talk about the effect of wind on ground track and crab angles. So this is a really useful one to look at. I'm going to do it like this, actually. Oops, not like that. Like this. So if you've ever been in a boat that's sort of crossing a stream, if there's no current in the stream, then you get no drift. And when you point the boat straight ahead, it's just going to go straight to the other shore. If you were in a current that's actually moving, so if the stream is moving this direction and you point the boat across the stream and just start going forward, the boat's going to drift sideways with that water. And so you'll end up actually landing somewhere at this shore. And so if you wanted to end up on the opposite shore, directly opposite, you actually need to turn the boat into the current a little bit to counteract that downstream motion to keep the boat aligned with this ground track that actually goes across. So that same sort of drift concept is the kind of drift that we encounter when we're flying. So just like with the river pushing us downstream, and we need to angle upstream to account for that, when we're flying, if there's no wind, we fly straight like that. But if there is wind, we'll drift off to the right, and so we need to turn into the wind to counteract that. So you can think of it as though to keep the airplane aligned with a ground track, you need to angle the nose into the wind. And we'll talk when we do our cross-country planning a little bit more about how we calculate how much we need to deflect into the wind. So for our ground reference maneuvers, we'll get a sense of what the wind is before we go up to fly, and then we'll kind of calibrate as we're actually flying to the actual conditions we're seeing. For our long cross-country planning, one of the things we're going to do is we'll look at the forecast winds, we'll predict specifically how much of a heading deviation we need to do. So maybe we're going to angle 8 degrees north or something like that, or 8 degrees, to the left. And then as we go out and fly, as we're on our long cross country, so we have a little bit more time in the airplane, we'll actually figure out what the difference between the forecast winds versus the winds we're actually seeing are, and we can kind of calibrate our correction angle as we're flying. So, okay, so the important takeaway from this part is that just like a stream that pushes the boat downstream, you need to angle upwind for, or upstream for. Same thing with wind, you need to angle into the wind in order to keep aligned with the ground track. That motion is called crabbing. So when the airplane is angled like this, that's crabbing into the wind. You're pointing the airplane more upwind so that you stay aligned with a particular ground track. And you'll hear that word crabbing pretty frequently. One of the places where we've already heard it actually is when we did our normal crosswind takeoffs and landings. There was this diagram of our takeoff where we move from this side slip into a crab angle. So that's that same thing. So this is sort of a different technique for staying aligned with the wind, but when we're flying, we want to use this crabbing technique. So we're just pointing the nose more into the wind. All right, so let's keep going on here. I'm also going to open up this one in a new tab. That's going to be useful. So the next piece of this then is we know that we have to correct for the airflow. We know we need to correct for the direction the wind is pushing the airplane. The next thing to talk about then is the effect of that wind on our bank angle and ground speed on the rate and radius of turn. And so let's look at this picture more closely. So if we were, for instance, going to fly a half circle, as we're going to do in one of these maneuvers, and there's no wind, all we need to do is set a constant bank angle and stay coordinated through the turn, and we would fly this nice even turn. And it would look like a nice kind of perfect half circle here. If instead we had this 20-knot wind that was blowing the airplane, this dotted line here is showing you the path that we were meant to follow. But if we didn't do any kind of correction, if we just sort of set the bank angle and let the airplane fly through the turn, the wind is going to push the aircraft downwind, and we would actually get this sort of ground track, which of course is not that nice half circle that we're looking for. So in order to complete this turn correctly, we actually need to turn more into the wind. That same thing we were looking at here, right? We point the nose into the wind to keep to the right ground track. So in order to do this half circle turnaround here, we would actually need to point the nose more upwind than if we had a no wind situation. If that doesn't quite make sense yet, when we talk about it with the actual specific maneuvers, you'll see a couple more examples of where that's important and how we then use it for these maneuvers. So the thing to keep in mind here is that we can't just set our bank and let the airplane turn. We actually have to increase our bank as we're moving faster to try and to make sure that we're holding the correct ground path. Again, if this isn't clicking just yet, don't worry. We're going to see 3 more examples at least of this, and we're actually going to go try it in the sim. So we'll get a little bit more time with that one. The other concept that we should talk about just a little bit today, let's see if I have my dual student. This should work. Okay, so you get to see a little bit more of the back end. I worry that I have complicated things. Somehow in my pulling from this, it didn't really work, which is too bad. Okay, VIT dual, that's fine. So let's talk about why this is. So if we go, let's talk about maneuvering speed. So maneuvering speed, this is a very long definition, and it's worth knowing that that definition exists, but I want to give you kind of the shorthand version of it, which is maneuvering speed, the shorthand and technically incorrect, but useful at least for where we are in training, of maneuvering speed, which is maneuvering speed is the speed at which the aircraft would stall or would stall before it exceeds the maximum load you can put on the airframe. So if you think like a Top Gun situation where you're flying really fast and you pull up really hard and you get all this G-force, that load factor, that pressure on the wings, from pulling up really hard. If you are flying really, really fast, you can actually put more G-force on the airframe than the airplane is designed to take. So this airplane has a 3.8 positive G load limit. So you can put 3.8 times the weight of gravity on the wings before you cause any kind of structural damage. If you are flying really fast, you can actually pull back on the yoke hard enough to cause more G's than that, and that can bend the wings is one thing that'll happen, but also it can cause the airplane to break in other ways that are more dramatic. And so to make sure that we can't that if we did pull back really hard, if we really tried to put the airplane through the greatest G-force that we could, if we're flying below maneuvering speed, the airplane will stall before we exceed the maximum load factor on the wings. So said another way, when we're going to be doing maneuvers like this, where we're going to be changing direction, or where we're going to be doing especially things like steep turns, or if we're in bumpy conditions, if there's choppy air, or if there's maybe mountain wave or something like that, where the nose is, or where the aircraft is getting bumped around through the air, we want to slow down below maneuvering speed to make sure that the aircraft would not experience any kind of damage from like a really strong gust, for instance. So not my greatest explanation of that concept, and I'm wondering actually if the thing to do would be to spend a little bit more time on maneuvering speed earlier, or even maybe a little less time on maneuvering speed now. Let me jot a note real quick to reconsider the position of this. Because I think it's important to know, because we're going to be using maneuvering speed, but I'm wondering if it's maybe more confusing than it's worth, and easier just to say, here's the speed we're going to use for now. I think maybe that's the thing to do. So at any rate, okay, so we'll call this a bonus for folks tuning into the live stream. I think with a real student, I would start with just the speed, and then later we can kind of backtrack to, okay, here's why we picked that speed. One thing to know, since we are talking about it, is maneuvering speed does change with weight. So if you have more weight in the aircraft, the maneuvering speed is higher. If you have less weight in the aircraft, the maneuvering speed is lower. We talk about why the physics behind that if anyone's interested, but for today, we'll just kind of breeze past it. Because we have 2 people in this airplane, I did a rough calculation of what that maneuvering speed would be for the approximate weight we would have, and we'll use 100 knots then for that. If we had the airplane fully loaded with everything that could carry, the maneuvering speed VA is 105 knots. So, okay. All right, let's keep going then. So talk about actually flying the maneuvers. So same sort of thing we do for all our maneuvers. We want to select a location without excessive traffic. We want to have a suitable emergency landing fields if we needed them. We want to select a safe altitude and appropriate airspeed for the maneuver. We'll check for traffic in the area before and after each maneuver. Again, we do that with our clearing turns. Maybe we'll also look at our iPad if we have traffic displayed there. And then we need to make sure we're dividing our attention between the aircraft control, traffic, and ground references. This is a good maneuver where we start. So if you remember when we were doing slow flight and stalls, we were thinking about, we pick a reference off in the distance, maybe the reservoir or a mountain, and we use that to make sure that we're keeping our heading straight as we're doing these things. To do that, then we had to divide our attention between what was happening outside the aircraft and what was happening inside the aircraft. We'll have that same sort of division of attention going on here. So you want to be paying attention to your airplane control, traffic around you, and then also the ground reference we're turning around. All right, let's dive in. So our first maneuver here is a rectangular course. What I'm going to do is I'm going to pull up all 3 of these maneuvers. I want to show you the overview picture so that you just have a sense of what we're going to do today. And then we're going to go out, we'll fly out to the practice area, and then we'll do an active pause there and actually set up to fly the maneuver correctly. So at that point, once we get flying, we'll pause and we'll look through each of the stages of the maneuver. So overview first, and then we'll dive into the details. Rectangular course, S turns, and turns around the point. All right. So here's the rectangular course overview. So the idea with a rectangular course is to simulate the traffic pattern that we fly every time we go and land the airplane. So you can notice the wind is coming from this direction. we're going to enter on the 45 to the traffic pattern. And then as we're flying downwind, we don't need to have any kind of wind correction on here. As you can see here, because the wind is just blowing us downwind. However, when we are on the base leg, this one, we need to have our nose turned into the wind, that crab angle, to make sure that we're staying parallel to this reference line. So if we didn't do that, we would drift out like that. And this would be kind of a classic shape for a new student. As they're first starting, they may not crab enough, or they may not crab correctly, and you get this sort of, the airplane gets blown out and then it goes way out here instead. So we want to make sure as we turn through this, we're actually going to turn more than 90 degrees to point our nose into the wind. And so we'll talk about that when we actually do it. Again, now we're turning upwind. It's actually a less than 90 degree turn because we've already got our nose pointed into the wind some here. So we turn upwind, again, parallel to the wind. And then as we turn our crosswind leg, then we have our nose pointed into the wind again. So we're crabbing once again to make sure that we're staying aligned. If we didn't crab correctly, we would cut this corner here. We just get blown backwards. And then we'll do that a couple of times. So there's an entry on the 45, fly around the traffic pattern, and then once we do a full lap here, we can exit off to the side like that. Okay, so that's one maneuver we're going to do today. Second maneuver is S-turns. S-turns are all about correcting for wind drift as we're turning. Turns around a point are similarly about that. What we're going to do is we'll enter on the downwind perpendicular to some long reference line like a road or something else similar to that. And then we'll turn around to form a equal, or it should be a half circle turn here. So if we're correcting for wind correctly, then it'll look just like a half circle turn. Wings level when we reach the road again, and then again we come back and wings level on the other side. So it should look like this nice clean S turn. This is another one where if you are not using your wind correction correctly, that's where you get this weird oblong shape. So we'll talk about how we do that when we actually get out there. But that's one of the big things we're working on, is that nice even. And then the last one that we're going to go and do is turns around a point. Again, we're going to enter on the downwind. So we'll enter like this. And then we're crabbing into the wind as we're on the kind of, well, we'll talk about how to do wind correction, but the same sort of thing, right? We have the wind is blowing us one way, so we have to account for that by crabbing. We're also going to be changing our bank angle because this is an important thing that I did not cover in here. Okay, so we're going to talk about that super quick before we get going. Flying turd, let me see what you got. When you... Good question. So when you turn into the wind and start crabbing, so when we're doing this sort of crabbing maneuver here, right? So we're pointing the nose more into the wind to keep our ground track along some whatever the line that we want to stay aligned with. The airplane will fly itself through that air mass as though it were flying straight, as though there were no wind, no drift. So we know that the air is pushing us because we're referencing something to the ground, but to the airplane, it would be as though it's flying through an unmoving air mass because to the airplane, it's flying within that air mass. And so it just sort of flies like normal, meaning the answer to your question is when you turn into the wind, you definitely have to use rudder for that adverse yaw we talked about with turning. So there's an initial bit of rudder in the same direction that you're turning to initiate the turn. But if you are established in a crab, you're just flying straight and level, no sort of changing inputs, then you shouldn't need any additional rudder. It should, unless you're in slow flight for other reasons maybe. But if you're just kind of in cruise flight and you have a crab angle established, you shouldn't need to use any kind of special rudder or any other kind of adjustments to it. And the reason for that is that the air mass that you're flying in, the airplane doesn't know. Like to the airplane, it's just flying like normal. There's nothing special about what's going on. We know that the air mass is moving, but the airplane doesn't know that. That kind of makes sense? Roger that. Thanks. Okay, yep. Good question. All right, so one of the other things that's really important here, I'm realizing I didn't have in the original notes and we should talk about is, okay, good. Glad to hear about it, is the rate of turn versus the bank angle. There is a really good picture in the p-hack that I should have had for this. Turn versus bank angle. So I'm going to jot a note to add that in here, but I think I can explain it sort of hand wavy enough. I think it'll be all right. So if we want to increase our rate of turn without changing our airspeed, we can do that by increasing our bank angle. So if you think about, you have an aircraft that's flying at maybe a 20-degree bank, you've deflected a certain amount of the lift vector into that horizontal plane, and that is going to then determine how quickly you're turning through, assuming your airspeed is constant. Then that's going to determine how quickly you're turning, your rate of turn, how quickly you're turning through that. If you deflect your lift vector further into the horizontal plane, so if you go from maybe a 20-degree bank to a 30-degree bank, that is going to increase your rate of turn. So you're going to be turning through you're going to be moving through the turn faster. So you've put more lift vector into the horizontal plane, and so you're going to move through it faster. The reason that that is important is because when we look at something like turns around a point, or S-turns really, are both the same sort of thing, we're correcting for wind, but the way that we correct for wind in these cases is by changing our bank angle. So yes, we're technically crabbing into the wind at like an instantaneous point, but that's not a super useful way to think about it. Instead, what you want to think about is as you're moving faster along the ground, you need to have a steeper bank angle so that you have a faster rate of turn. The reason for that is, let's say that this is a 20-knot wind blowing us downwind this way. As we're moving across the ground at, say, 100 knots, that 20-knot wind that's blowing us is actually making our ground speed 120 knots. And so we're moving so much more quickly this way, we need to have a steeper bank to make sure that we're turning more quickly as well, right? So we're moving over the ground more quickly, so we need to finish our turn more quickly too. So steeper bank. If we're flying upwind, so now we're moving at 100 knots, but we're getting blown backwards at 20 knots. That means our speed over the ground, our ground speed, is 80 knots. Because we're moving so slowly over the ground, we use a shallower bank because we want a slower rate of turn, right? We're going to move through this segment of the circle much slower, and so our rate of turn should be slower so that we get to this point out here at the correct, so that we keep this nice kind of equidistance from the center of the circle. So the thing to remember for that is, as you're moving downwind, you want to have a steeper bank. As you're moving upwind, you want to have a shallower bank. And then you're transitioning between the two as you move either from downwind to upwind. So you see they have kind of steepest bank, shallowest, steeper, steepest, and on like that. You see the same things in the S-turn. So it's the steepest bank, right? In this case, we're moving, this was the direction of the wind, so they flipped the direction of the wind on us here. But so now we're entering downwind, steepest bank right at the beginning, moderate bank, shallowest bank, and then shallowest bank, moderate bank, steepest bank as we're moving back downwind. So when we have a tailwind, we want the steepest bank. Headwind, we want the shallowest bank. All right, so when we go out and try all of these, we'll kind of we'll practice all of those different elements of it. I'll also mention some ways when you're going out to practice this yourself to make the maneuver a little easier to fly. Oops, that's not quite what I wanted to do. There we go. But for now, the important thing to remember is when you have a tailwind, you need a steeper bank. That'll increase your rate of turn and get you following this correctly. And when you have a headwind, you need a shallower bank. All right, so last thing before we take off, it is very, very useful to know the winds aloft when you're going to go and fly. There are a couple of things that we can reference on the airport that tell us the wind at the airport. So that would be the wind that we're seeing on the ground. One is the windsock, which I don't think you can see over here, but I don't have it showing right now anyway. The windsock with the add-on that I'm using is, I think, still flipped backwards, so we won't trust this windsock. When we see it, I'll point out that it's 180 degrees reversed. I got in contact with the creator of the add-on, and it sounds like he just noticed this as well, and he's going to go and fix it in a future update. So there's that. There's also the ATIS that we would get that would tell us the local wind. That gives us an indication of what direction the wind's coming from. See, Nightbot deleted something. Shoots is posting. Sorry about Nightbot filtering that one. Shoots, that's a good link. So I'll repost what Shoots was saying. Yeah, windy.com. Okay, so Shoots was saying windy.com is a site I use for winds at a different altitude. That's a great reference for it. Yep. Yeah, for that exact reason, because you want to know, you can get the wind at the airport, but often the wind at altitude, so we'll be flying at 1,000 feet for these maneuvers, that wind may be a little bit different. And so it's nice to actually check what the wind is up a little bit. So if I go, one way that I like to do it is I'll get it for as part of my pre-flight briefing. So if I go to the winds aloft table that shows up here, you can actually see that we have winds. It's showing me winds at 500 and 2,500. ForeFlight does some interpolation based on the location of the airport. So when we do our cross-country planning, this is a useful tool, but we probably won't use this because we want to do it using the official sources and talk about why we do that. But as a quick at-a-glance thing, you can see that we have wind coming from about 290-ish, true, not magnetic. So we'll talk more about that when we go through the briefing, but true heading of 288, so 290-ish. And it looks like we're going to have somewhere between, if we went out right now with live weather, 14 knots and up to 24 knots at 2,500. So at 1,000 feet, we might get like 20 knots or so. It's a pretty strong wind actually to go and practice these. Because of where we are, sorry, 1 second. So because of where we are in, this is sort of jumping ahead, but I think it's useful. Because of where we are in California for this, there's a certain amount of correction between true and magnetic heading. Even as I'm getting into this topic, I think it's best to do this as a whole discussion, not to just like quickly mention. Let me see how to, first of all, I got to change this around. What's the best way to talk about this? Okay, so we can just look at this real quick. So our true North Pole, if I take my little pen, is right here at the top of the grid, right? But the magnetic North Pole, the place where the compass actually gets drawn to, is somewhere down here. And so actually I think it might be even in the Hudson Bay. It's somewhere like around this area though. And so when we hear a true heading, that is going to point us to the North Pole, but a magnetic heading is going to take us to the magnetic North Pole. And so there's a difference angle here that is included on the charts. And that angle is where we are, 13 degrees 30 minutes east. So what that means is that when we see the, go back here. So when we see this true heading, which is we get our winds aloft table in a true heading, and we want to convert it to a magnetic heading, we need to subtract that easterly deviation. So 15 degrees east, subtract that off means that where our winds aloft says that's coming from 283, so that's 283 is, oops, I got this backwards, like this. So that means that our wind is coming from over here. But when we see it on our compass, when we're actually flying around in the airplane, it's gonna appear as though it's 15 degrees off this way. So it'll be it'll read on our compass at, instead of, let's say this is 290, we'll keep in our mind, instead it's going to read at about 300. So just sort of shorthand so that we can remember it. Again, when we do our cross-country planning, we use the very specific numbers, but what I'm going to remember for this flight is when we're flying, we're going to expect our wind to be coming from 300 when we have it on our compass, and then we'll start to make some accommodations as we actually get flying. I hope that was clear enough. So let me know if you have any questions on true and magnetic. I think I'm going to make a note on this one. For true and magnetic, and if we should talk about winds aloft, because I think this is, I think, an example where the live stream format kind of falls a little bit on its face, because with a real student for all these flights, before every flight, we would have done the full briefing, and so we would have already talked about a lot of the aspects of what's being shown, the winds aloft versus the ATIS versus what we hear on the radio. Um, and so that topic would have already come up. But I'm wondering if I should have it explicitly in an earlier lesson plan, maybe as part of the first lesson. It just seems sort of complicated, but anyway. Uh, Ocean, National Ocean and Atmospheric Administration, NOAA, has a declination calculator. So, Shoots, would that give you that same sort of like 13 degrees east thing we're seeing on the sectional? Is that okay? So, I also just realized I should have thought about this. The for flight number that I was using to reference, it has that like, on the very bottom right corner, 306 degrees M. That's magnetic. So actually, the way that I was doing this was, it's okay for illustration, but it really would have been like, like this instead, minus 13, and then we go. Anyway, that's okay. Um, all right, let's get flying here. Is to include some resources. Yeah. Thanks, Shoots. I think that's a good idea. Um, and resources meaning like the NOAA declination sort of resource, or you mean like, because I mean, one thing I'm immediately kicking myself is for not having a picture of the difference between true north and magnetic north, and not having some of those like memory mnemonics ready to go. Um, so I'm like, the classic one is east is, you know what? Actually, before I do that one, yeah, east is least, west is best for converting from true to magnetic. So when you have east, then you subtract east is least, west is best. So east is least. Did I subtract that wrong? I did that wrong too. Did I do that wrong? I'm like second and triple guessing myself. Yeah, I did. I did that backwards. So let me do this again. Sorry, folks, and sorry for the confusion. So let's do this a little bit more um, correctly here. And what I want to do is, we actually have our lines of latitude are charted, and we know that this would be 270 true, right? We also know that our wind aloft, we can use 290 just as a good reference, but we expect to be coming from 290, again, true. So that's 20 degrees off from 270 would be more or less here. When we're converting from true to magnetic, east is least, so we subtract 13 for our local, um, for our local difference between true and magnetic. And so that's going to give us, whereas this would be 290 true, degrees true, then we would subtract it and get here would be about 2, so it'd be 277, but we can use 280 degrees magnetic. Let me confirm that on here before I, okay, yeah. So real rough sort of just drawing these things out, but sure enough, Foreflight agrees with that, which is 277 degrees magnetic would be 20 degrees off from here. So, okay, so 280, sorry that I had that flipped around in my head. And yes, I will add some better resources and some pictures and things to actually explain that a little bit better. Manavis, so the resource I mentioned are just what I'd use in simulation. Okay, cool. Okay, yep. So I'll jot a note for that too. Resources also for use in sim. Yeah, and one thing you can do in sim, I will show. Let me show this because this is pretty helpful for briefly doing. It's yeah, the shoots, the one that you posted I think is great. That windy.com reference is super useful. Another one that you can do in a particular type of plane, and let me just flip over to sim here real quick. So I'm going to go into developers and actually just change out to a different plane. And the reason is that planes with G1000 will also have a wind indicator, so you can actually see while you're flying what the current wind is. Apologies, I believe it's aircraft selector. So if I go to, instead of, we're using the 6-pack Cessna 172, if I go 172 G1000, load that up. In the PFD here, you can go to PFD options and then wind, and then choose how you want to display it. So we can leave option 1 for now. There's 3 different options you can play with. And what I'm going to do actually is really quickly start this. I'm just going to use Control E. Yep. Okay. And let me slew up real quick just so we can see what I mean by that, that wind indicator. Get this controller loaded. I guess I can do it like this. Oh, nope. There we go. All right, great. So if we pop up to a little bit more altitude, so let's say we go up just like 1,000 or something like that. And then you can see actually, so I have too much power in here. We can go 24,000 or 4,000, 2,400, excuse me. But you can see in this bottom area, that tells us our headwind and our crosswind and what direction it's from. So if we turn into the wind a little bit more here, you can see that our headwind is changing. We're getting more, our crosswind is changing. We're getting more of a headwind and our crosswind's dropping. Because it's live weather, I think it's picking up some of the like differences here. Usually it's a little more stable when you use like set your own wind, but you can see, so as I'm turning left here, so I'm continuing to bank. Now we have a full headwind. And so sure enough, our expected for where the wind was coming from was 280, 277, and sure enough, our actual direction the wind is coming from is pretty doggone close to that, 276 in the sim. So right now we are flying directly into the wind at 277, but if you just want a quick reference in the sim, this is a nice way to see that. So, okay, hope that's useful. That's probably my most frequent way if I don't want to do like program the weather in the sim, and I don't necessarily trust their alignment, because like the sim is also doing its own wind calculations. I'd rather just know what it actually is in the sim, and so this will tell you that. Okay, let's go, and I'll just leave developer mode on. Let's restart here. I'll tell you what, for time, I'm actually going to go back and start right on the... No, let's do the whole thing. I think that's good. Okay. So we're going to do live weather here. It's a pretty windy day. In fact, I don't know that I would want to go out. Get the latest weather for Palo Alto. So we'll listen to the latest ATIS for Palo Alto, and we can talk about what each of the different numbers mean for it. It's a pretty windy day, and we have a pretty heavy crosswind, and so we may, flying in the real world, we may say we don't want to risk this sort of thing. Flying in the sim, I worry I'll embarrass myself in the crosswind takeoff as it gets a little jumpy, but that's all right. Oops. This is not the aircraft I wanted. And actually, part of the reason that I like teaching in the 6-pack ones is I think the G1000 is a really, really nice tool, especially as you get further into flying. The tricky piece with it is it gives you a lot of handy kind of tools like that wind correction, when it would be good to know what to look for on the ground to identify the wind instead of needing to rely on the G1000 to tell you. One of the ones that we would rely on is this windsock off in the distance. Like I said, the windsock is 180 degrees backwards with this add-on, so that's unfortunate. We'll just need to keep that in mind while we're taxiing in the sim, but typically that would be a good surface indication of it. All right, so let's go through our normal checklist, and I have a iPad version of this, so hopefully you can see my checklist as well. If you're flying in, there's a couple of checklists that work really well. We can use, actually, the Checkmate one is probably the right approach here. Oh, I don't have the Checkmate for that one. So when I'm flying in the Piper Archer, often we'll use this Checkmate checklist, which is a really useful sort of reference. For the 172... I typically use my own customized checklist because I fly it enough that I like to have specifically how I think about each of them in place. Seeing some background audio here. Let me make sure it's going okay. Sounds good. Okay, so let's start running through our checklist. So pre-flight inspections, this will be all the things that we do when we walk around the plane, make sure everything looks good, make sure we have enough fuel. For the sim, and for the sake of time, we'll say that we've already completed that. Before starting the engine, pre-flight checklist complete. Good. Oops. Passenger briefing. So our standard safety brief for passengers, especially highlighting the seatbelts and how to use them. Okay, good. Brakes test and set. So I'm going to turn my parking brake on. I'm going to get rid of my yoke so we can see below here. Make sure if my parking brake is on. Also would pump my brakes a little bit, make sure that they have fluid in them so they actually seem like they'll work. Circuit breakers, run our fingers over the circuits here. Make sure nothing's sticking out. Electrical equipment off. I typically leave the beacon on so I have a reference. Everything else is off now. Good. Avionics master switch off. Fuel selector valve on both. It's on both. Fuel shutoff valve on. It is on. Avionics circuit breaker check in. We include that in our original circuit breaker. Actually, I'm going to remove this one because that is part of my circuit breaker check. Anyway, some aircraft will have the circuit breakers may be over on this side, and so that's one reason why you might have another item on that. ATIS. Let's call the ATIS and get it. We can actually listen to the real ATIS today, and I'll jot down what my notes would be for that. Here's the Palo Alto ATIS. I'll jot down, and one useful reference is in ForeFlight, they actually have a template for this, so that'll tell you the different parts you're about to hear. Over time, it's good to start working on memorizing these, the order of these elements, because it'll be the same every time you hear the ATIS. So it's just a useful thing to start working on. Again, with a student, we would have been hearing this every day and kind of starting to build up how to write it down. And also the student would also be writing it down. So If you like the template, that's great. I've had instructors who much prefer that it just gets written down in a blank sheet. So you could do this exact same information, whatever you're going to jot down. I like the template, and it also lets me quickly reference back to it. So I know that we're at Palo Alto, and here is the ATIS.
For runway 31, notice the airman 5 NOTAM in effect for Palo Alto Airport. Hazardous weather information available on flight service frequency. Caution for bird activity on and in the vicinity. Feedback hold short instructions and runway assignment. Advise ground control departure request. Advise on the contact information. So. Information Kilo 1947 Zulu observation, wind 270 at 15, gust 21, visibility 10, sky conditions ceiling 2,500 broken, temperature 1.6, altimeter 2974. Visual approach for runway 31. Notice the airman 5 NOTAM in effect for Palo Alto Airport. Hazardous weather information available on flight service frequency. Caution for bird activity on and.
I'm going to call back and get the temperature and dew point because I missed those.
Information Kilo 1947 Zulu observation, wind 270 at 15, gust 21, visibility 10, sky conditions ceiling 2,500 broken, temperature 1.6, altimeter 2974. Visual approach.
Okay. So let's talk about what each of these means. So Kilo is the ATIS information identifier that we have. So that's what will tell the tower that we have when we are starting to taxi. The time, this is in Zulu, so offset from California, depending on daylight savings time or not. So currently it's 1957 Zulu, off by 8 hours. It's 11:57 here. If we go to this gets the new ATIS comes out every hour, about 47 minutes past the hour. So this is a really well timed ATIS. Sometimes a couple minutes after that. I don't think I've ever seen it before that. But you'll know then, so we are getting the ATIS at 11:57. We have a while before this information is going to become outdated. If it was like 11:45 and we were going to go get the ATIS, we may want to wait a couple of minutes just to get the next one. Otherwise, when we call them up, they may say, listen again to the ATIS and get the new information. So, okay, wind 270 at 15. So the memory mnemonic we use about wind is when you hear it, it's magnetic, because if it's written, it must be true. So it's sort of a joke on, anything written is true. Obviously, not the case in the real world, but that's sort of the joke memory mnemonic, and it works really well for VFR flying. So if it's written, it must be true. So when we were looking at our winds aloft forecast written, and so the compass. So the compass direction on here must be true, right? If it's written, it's true. What we heard on the radio, so we didn't see it written, but we heard it, was 270. So that must be magnetic. It's not written, so it's then magnetic. Another one that's sort of interesting you can look at then is if you go to the METAR published by the airport. So if we go here and see it, you'll see that it's 280. So I'm looking, I can't really show you where I'm looking, unfortunately, but it's sort of this right at the top of this box. It's that same information we just got. So there's Palo Alto, the time in Zulu, date and time in Zulu, and there's that wind, but it says 280, 15 knots, gusting 21. And it's 280 because the true versus, because when it's written, it must be true. And so this is true course to the nearest 10th of a degree. To the nearest 10 degrees. So true winds at 280, but remember, if it's from true to magnetic, we subtract our east. I'm totally spacing on this word. Let me get this word too, because I know this and should have it immediately on hand. Oh no. Yeah, okay. So compass variation. So where we are currently, because true north and magnetic north are not in the same location, we have a certain amount of compass variation. We are 13 degrees east variation, and so to go from true to magnetic, east is least. We subtract from our true to get to our magnetic. So if we take 280, this meter we have written here, subtract 13, that gets us to, rounded, it gets us to 270. So that's why the wind that we see written here is in true, whereas the wind that we heard on the radio is magnetic. The reason that they do magnetic for this is because our runway headings are all magnetic as well. So they're giving us the wind in the frame of reference that we're going to have in the plane. So all of our compasses in the plane are all magnetic. Our heading indicator will be set to our magnetic compass, so this will also be magnetic headings. The runway number is based on a magnetic compass heading, and so everything we're doing in the plane essentially is magnetic heading based, and so they give us the radio, the ATIS over the radio in magnetic. Okay, so 270, so let's look at what else this tells us. So we know that our runway is 3-1. We know that our wind, and this is 3-1, again, runway is magnetic. The wind is 270 magnetic. That means that we have a 40-degree difference between our wind and our runway. We know that we could do the actual sine and cosine of 40 if we wanted, but our memory aid when we talked about crosswinds was 30 degrees off is 1/2 of the total wind speed, and 45 degrees off is 75% of the total wind speed. So we know that we're going to have our runway heading is 3-1, so it'll be like this. Our wind is coming from 2-7, and so our crosswind component here is going to be about 75% of 15. So we can use, let's say, just 12. And then our headwind component is less important because that's just going to improve our takeoff performance. But that would be the cosine of 40, I guess also 75%, so also 12. We're going to have gusts up to 21. 75% of 21 is about a little more than 15. So this is a crosswind gusting to 15. If I was looking at this with a student, I don't know that we would want to take off today. And the reason is that if the wind ends up being even a little bit stronger, we're going to be pushing up against or if we get a gust at our takeoff moment, all of a sudden we're pushing up at our demonstrated crosswind for this plane. Remember, the Cessna has a 15-knot demonstrated crosswind. That's a lot of crosswind to be out, especially in gusty conditions. There's a conversation to be had about whether or not maybe we wait a little bit longer to see, depending on what the weather is expected to do. Maybe it's going to be improving through the afternoon. We say, okay, let's do a little bit of ground and then we can go out, that sort of thing. For today in the sim, it's actually great because we can talk about good crosswind takeoff technique and go and work on these things. And as you develop your proficiency as a pilot, going out on windier crosswind days, up to a point, of course, but windier crosswind days can be really helpful to start honing in on that crosswind technique. Other things that are being read out of here, so our broken at 2,500. All of our maneuvers today are going to be at about 1,000 feet, so our ceiling should be high enough. That'll give us 1,500 feet above where we're going to be flying. On our cruise over there, we'll fly over at about 2,000 feet, and of course we'll look at the actual weather going on as we're flying. I just moved the weather minimums discussion. So there's a federal law on how close you can get to clouds depending on the airspace you're in. I just moved that into a much later lesson. And I still think that's the right thing to do. Okay. So later on we'll talk about how close you're allowed to get to clouds, but for now we can just say this is okay for what we're going to be doing today. And the last thing that I noticed on here that's sort of interesting is the altimeter is really low. So remember, 2992 would be our standard altimeter setting, and so we're quite a bit lower than we would normally be, or than a standard day. So a low pressure system going on around us usually indicates bad weather. So okay, Great. That was a nice little deviation. So we had our ATIS, good to go. Let's get our engine started here and actually go out flying. So throttle 1/4 inch open, mixture to idle cutoff. Propeller area is clear, and we'll call it before we start the engine. Master switch on, flashing beacon on, auxiliary fuel pump on. This is our priming, so we bring up our mixture, watching our fuel flow here. It should be 4 seconds once we get fuel flow. Okay. There we go. 1, 2, 3, 4. Mixture to idle, and turn off the fuel pump. Okay. Got an eager dog in the background. All right, and so now we have primed the engine. Before we start, we're going to call out clear out of the window. So we'll say clear, and then look around, make sure that no one is standing in our vicinity or that no one yelled back to us to say to wait. Okay, great. And I should be checking these off as we go. And then we're going to turn it to start and advance the mixture as soon as it catches. Okay, there it catches. Bring the mixture all the way in. Make sure the engine sounds good. My throttle RPM is pretty low. There we go, to 1,000. And immediately I'm looking for oil pressure. Again, on the sim, it seems to run a little low on oil pressure. In a real plane, this would make me a little more nervous. But that's sort of what we're expecting to see, at least in this plane. So said it's okay. Oil pressure, avionics master. Then we turn on, turn the radios on and set. So this is where we would set it to our ground station, since we already have the ATIS. I like to do ATIS in the second radio down here, and have that ready for when we come back in. And in fact, I think I will do that because when we come back into the airport, we're going to want to get the new ATIS. Okay, so then we'll set this one to 135. Sorry, you can't really see that very well. 135, 275. Okay. Let's make sure that I'm. Yep. Okay. There we go.
Okay, 25. Wish I could see this while I was doing it.
I know there's a way to turn off that. There we go. Okay. 135, 2.275. Great. And we can put that up in there. So now we have our COM2 set up to be our ATIS, which we can listen to by pushing that. Okay. Master radios. We can retract our flaps, which we currently have at 0. During our pre-flight inspection, we would have put them all the way down. Connector headset. Mixture for taxi. Okay. And so we typically, what you'd like to do on this is to use the procedure to find it, which we did in an earlier flight, and then you can reuse that setting when it's the same essential weather out. So I'm going to reuse the setting that I had previously found. I'm not just like wildly bringing it back. If we were in the airplane, you probably use a reference like your thumb, often like the length of the last segment of your thumb or maybe the width of your thumb, depending on the aircraft. In the Piper Archer, you can use it to a certain letter on the mixture indication. So that there's a little, how do I describe this? The setup of the cockpit is different in that you can use a reference that's actually in the word mixture. You can put it to a letter of mixture. Navigation lights. All right. So we will, as we start to taxi, then we're going to turn our strobe nav and taxi lights. Okay, before takeoff, so this is our run up. So let's call up our Palo Alto ground and ask for permission to taxi. So we're going to have our scratch pad ready to go here. Erase this. And so I typically jot my taxi instructions in here just to have them. So we'd say something like San Carlos, I'm sorry, I keep thinking San Carlos. Palo Alto ground, Cessna Alpha Lima Tango India Sierra on Papa with Kilo for right down departure. And then they would respond with Cessna Alpha Lima Tango India Sierra, taxi runway 30 via Yankee Terminal side, Yankee 1, Zulu, advise run up complete. And then we'll say taxi via Yankee Terminal side, Yankee 1, Zulu, 2 runway 31. You don't need to say back will advise, but you could say will advise run up complete. Again, nothing wrong with reading back everything that they said. As you get more proficiency with it, you can pick out kind of the required readback things, but especially for early flight training, that's just fine. Okay, and then we go back into our map. We can draw what that is. So implied that we're going to follow Papa down to Yankee Terminal side, which is this one. We go to the run-up area, do our run-up, and then Yankee 1 to Zulu to 3-1. So that's what our taxi instructions are going to look like. We can keep this up then while we actually taxi. So turn our lights and take our parking brake off. And the first thing we want to do is test our brakes before we roll out. So I'm just bringing in just enough throttle to get the airplane turning. Okay, good. And started to go left right away. Oh, you know what I'm forgetting? Which is critical. So we have a wind at 270 at 15 knots. So our 270 is right here. So we have quite a bit of crosswind from headwind from the left, and so we need to use our proper wind deflection on our aileron. So I'm going to turn like this. Okay, so again, I'm going to bring my power up. Get the airplane taxiing here. Okay, there we go. And I'll test my brakes right away. Okay, good. You probably have your CFI test their brakes. Really getting blown into the wind here, which is pretty interesting. So I'm using a little bit of, let me change my perspective here. There we go. A little bit of right brake just to turn. As we come through the wind, then we want to go to the other direction. So now the wind is a quartering left tailwind. And so we need to have our yoke forward, and then like we're diving away from the wind. Okay, and then through all these intersections, of course, we're checking for traffic to make sure that there's no one ahead of us. Staying aligned with the yellow line. Oops. Okay, and then as we come through the wind again, we're going to need to deflect our ailerons correctly again. Oops. And when it's a headwind, we don't need to push in the yoke, so we just turn the ailerons correctly. Okay. Turn into this spot. Get my nose wheel aligned. Okay, I'm a little off. I'm gonna bring just a little bit of power. Okay, good. And wind is off to the right now, so we'll hold our ailerons like this. Okay, great. And we'll hold that through for the run up. Parking brake set. Turn that on. Passenger seats, upright position, seat belts, cabin doors. Maybe push on the cabin doors. Flight controls, free and correct. So I'm going to box my controls fully. So all the way out, in, around, down. And then I also want to be checking that they are correct. So looking out my window, when I roll to the left, I should see that my left aileron goes up. So the way that my yoke is pointing is the aileron that is up. And sure enough, that is the case. See if I can lower this a little bit. And then if I go the other direction, so I roll to the right, and then that right aileron is up. So that's good. And then we can look behind us. So I'm going to push the yoke forward and pull it back. So let's see if I can get us up a little bit higher here. There we go. So if I push or pull back, elevator goes up. That's good. Push forward, it goes down. Okay, good. And now let's reset our view here. And we want to hold our wing correction for the rest of the run up. Okay, good. Looking good. Flight instrument check and set. Our attitude indicator looks okay. Our altimeter has already been set by the sim, which is sort of interesting. Let's use the one that we actually got from the real radio, even though it's different from the sim. So 7.4. Well, that's what we have, 7.4. Great. All right. And then we also want to set our altimeter in our... That's funny. So it uses millibars. In a airplane that you're actually flying, it would use the same as the altimeter would be in inches of mercury, the right indication. But that's okay. So this is already set then. Good. Kind of convenient from the sim. Fuel quantity. We have 13 gallons of fuel on both sides. Should be okay for our hour-long flight today. We'll do our run-up check. So we're going to go mixture rich, fuel selector, reselect, or double check both. Good. Throttle to 1800 RPM. Bring that up to 1800. Set my, there we go. Okay. So there is 1800. Oops. Pushed out it just a little bit. Okay. And then we go check the left magneto. And we get a drop of 100. Get back. And check the right magneto and a drop of 100. Okay, good. So remember, we're looking for a maximum RPM drop. Can't be more than 150, and also a differential, so they can't be different by more than 50. So for instance, if we on the left magneto saw a drop of 25, on the right magneto we saw a drop of 100, that would be a problem because it means that our magnetos are working, they aren't producing a reduction in power to the same amount, and so something is probably wrong with one of the magnetos on whatever one is is reducing more. And so that it just indicates there's something wrong with the magnetos. You probably want to get checked out by a mechanic before you fly. Look at our vacuum pressure. So we're in the green, good. Engine instruments and ammeter, so we are charging, which is good. Normally this is just barely above 0, but in the sim it showed a lot. Annunciator panel, everything looks good. We'll give it a test. Good, they all light up like they should. We check idle, so we'll bring this all the way back to idle. Good. Okay, and it idles just fine, so we'll bring it to 1,000. And again, we want to lean for taxi then when we're done, so we'll bring it back to our taxi setting. Heading indicator set. So that is a reminder to set this for the runway takeoff. Now we're going to actually be, although our runway heading is 310, we're going to set it to 320 because, well, actually we'll do 310. But remember that when we take off from 31 at Palo Alto, we need to deviate to the right. So let me make sure I can actually see. Oh, I see what's going on here. Okay. So we'll set it to 320. I really wish this always covers up what I'm trying to do. I may need to disable that. I know there's a way to get rid of the tooltip. I like that you can see what I'm doing. Like it labels all these, so I don't even have to call them out. It just tells me. Or it tells me, but it also tells you. But it may be worthwhile to get rid of that for blocking our view. Oh, sorry, I said I was going to do 310, and I still think that's the right thing to do. Okay. Strobe lights will leave on. Radio avionics set. We set that before we left. Nav GPS. We can leave it as it is. This is fine. Oh, this is saying to switch to GPS mode for our autopilot nav. That's also fine. We can do that. Okay, autopilot, we will check this. We want to make sure we can overpower, so we'll turn this on. We can set to the heading mode. Oh, it automatically, okay, so it's set to the heading mode, and we should see it turn right. Good. If I then pull it to the left, I can't overpower it, so this is a problem with the sim. In the real airplane, of course, you're actually pulling a motor to all the cables, so you're trying to make sure you can overpower the servo. I can disconnect it, though, and it does give back control, which is good. And then we could try also the autopilot disconnect on here. So we again engage autopilot, and then we should be able to hit this disengage autopilot button, and it works. Good. Okay. Manual electric trim. That's on my yoke here. Good. I can use it. I'll set my trim for takeoff. So I'm looking to see that this white line is aligned with that white line. Good. Bring it down just a little bit because get it. Okay. Wing flaps to 10 for takeoff. and brakes release. So I usually leave the wing flaps up at this point so I can see under easier. Otherwise, if you have the wing flaps down, it kind of obstructs your view a little bit. I also include the wing flaps in my lights, camera, action for takeoff. So that's part of the action before we cross the threshold for takeoff. All right, so run up complete. We would go and say Palo Alto ground, Cessna Alpha Lima Tango India Sierra run up complete. They'd say something like Cessna Alpha Lima Tango India Sierra, taxi up 2, hold short, Yankee 1, contact tower. We'd say taxi up 2, hold short, Yankee 1, contact tower. So get rid of my parking brake, bring up power. Let me get rid of this yoke so you can see what I'm doing. So I'm slowly bringing up power, just enough that I can start taxiing here. Okay, there we go. A little more power than I expected. Oop. So then I'm getting to my yellow line. And now as we move through the wind, now it's becoming a left headwind, so we're going to rotate our ailerons to the left. Taxiing along here. Okay, oop, getting a little faster than I want. So my power is already at idle, so I'm going to get it on the brakes just a little. Okay, and I'm not quite on the yellow line as much as I'd like. But I like that I'll be able to turn here. Okay, great. So bring the power to 1,000. And then we switch over to tower. So we'll switch here and we'll say wait for 4 seconds. 2, 3, 4. Palo Alto Tower, Cessna Alpha Lima Tango India Sierra, Shorty Yankee 1, ready for departure. And they'll say something like Cessna Alpha Lima Tango India Sierra, line up and wait 3-1. So we'll say line up and wait 3-1, Cessna Alpha Lima Tango India Sierra. Okay, so they have told us that we can line up and wait on 3-1, but that we are not cleared for takeoff. And so what that means is it is a clearance to cross that runway holding position marker, those yellow lines. So, okay, now as we're crossing through the wind here, we also have some wind correction things to do. So now we have a quartering right tailwind. As we turn through this, then it's going to move around to be a quartering left tailwind. So, oops.
Approaching runway
Okay,
31.
Let me pause here real quick and talk about something. So before we cross this line, I want to do lights. So that includes turning on our landing lights, camera. And so we have our transponder set to 1200 VFR, and it's an altitude reporting mode. So that's good. And then action. So I want my flaps at 10. Trim is set. So I check these 3. So trim is set, mixture rich, flaps to 10. Okay. And then time. So I want to make note of the time that I'm actually taking off here. So it is 12:24. And I might jot that down, especially for IFR flight, you would jot that down. So I might do something like 12:24. Okay. And now we can start going through here. As we're taxiing through, we're looking for traffic, make sure no one's coming in on final that we would be surprised about. Okay, looking good. Let's get back to my position I want, good. And so we're scanning the traffic pattern. Now I have wind coming from my left tailwind now. So I have my elevator my yoke forward and to the right. Now it's becoming a left headwind, and so we rotate this to the right. Okay, and we're looking for traffic through this whole thing. We really want to make sure that there's no one in the traffic pattern, or at least that the tower has acknowledged to us whatever traffic that we are expecting. So, okay. Remember that the windsock for this simulated add-on is lying to us, so the wind is actually coming 180 degrees from where it says. Our clearance was to line up and wait 3-1, so here we are at runway 3-1 at the end, and so we can stop here. Again, when we idle, we want to idle at 1,000, and we're waiting for them to tell us that we're clear for takeoff. A couple things we should check. So our heading indicator we set was for 3-1, the runway. We see 3-1 in front of us. We see 3-1 on our magnetic compass, and so we are facing 3-1, the runway that we were cleared to line up and wait on. So that's our confirmation. Okay. And so now Tower would probably call us and say something like, oh, we're going to do a right Dumbarton departure. So that means we're going to fly out to this bridge here. Then we're going to take a right. And then as we get out, we need to be clear of this Charlie airspace. But we're actually going to do our maneuvering here today. I'm going to try going here. And we're going to stay under the Charlie, which starts at 1,500. So we'll talk more about airspace later. For now, just know that we're gonna do our maneuvering at 1,000 feet. And we'll stay below the Charlie. There's a couple of other places you can go. You can go over here to do practice is okay. And there's a really nice area with a real student on a first flight. I'd probably go all the way over here. It's a little bit further of a flight. It's a very pretty flight, but it's a little bit further of a flight. But there's less airspace to contend with, and there's some really nice emergency landing options. Anywhere we practice, we're going to have emergency options picked out beforehand. So we'll talk about, for this area, our emergency landing options. The reason I really like the one that's further away is there's a actual runway there, and so you have the emergency landing option of an actual runway, which is nice. But it's a private runway, so it's not like there's traffic all around you all the time. Okay, so quick sidebar on where we're going. So they'd say something like Cessna Alpha Lima Tango India Sierra, clear for takeoff, runway 31, right Dumbarton departure. And so we'd say Cessna Alpha Lima Tango India Sierra, clear takeoff 31, right Dumbarton departure. So we've done our lights, camera, action, time already. So we're going to bring in power 1, 2, 3, 4. We're using right rudder to keep ourselves aligned with the center line, and then we're slowly feeling out how much wind crosswind we're going to need to do our crosswind takeoff, just the same as we talked about before. So we expect to take off on just our left wheel. There's our left wheel, and we roll up, and then immediately we want to start crabbing. So we're still climbing out at 74, and you see that my nose is pointed a little bit to the left to account for that crosswind, so that we stay aligned with the center line, but we're climbing out a sort of nose pointed to the left, that crab that we talked about. So there's 74, we're at 200 feet, we'll bring our flaps to 10. And I'm flying in attitude, so I'm checking my airspeeds occasionally, but really I'm flying the pitch attitude, the sight picture that I have for 74 knots. It is gusty, it is a little bumpy, you can feel it in the plane. When we're doing our maneuvers, I may go and reset this a little bit. While we're in the traffic area, we're always looking for traffic, making sure that there's no one coming in odd directions or that's going to interfere with us. So we'll be looking out to our right and our left, checking our altitude. So we're going to climb up to 1,200 for this first little leg here, and then we'll cross over there. So yeah, so it's pretty bumpy up here. You can see in the sim. I got a nice rainbow though. That's cute. Okay. So there's 1,200. 50 feet before, I'm going to start to level the nose, bring the power back to 2,400, and then get to my sight picture for straight and level flight in cruise. So 2,400, climbed a little bit, scanning for traffic. Okay, and then initiate the turn. As we roll in, we use a little bit of right rudder, and then as we're in the turn, we hold that. We don't hold the right rudder, we just center the ball. And turning off here for my right Dumbarton, a little bit too much back pressure, so I'm starting to climb. Okay, and then roll out. I'm gonna follow along this bridge as a reference point just to get us sort of out and along the way. So we are going over to those red salt flats that you see to the right, kind of in the distance there. So that's this area here. These are a nice, relatively close area to use for ground reference maneuvers. I had been asking around to some other CFIs in the flying club I'm a part of to see where they recommend. And I will say that there's a wide variety of opinions on which ones to use and why. Um, like I said, I think for this actual lesson, not simulated, I would go over to that one where we have an actual runway that we could land on in an emergency. Um, but for us, for now, this is kind of nice. It won't be quite as long a flight. I can just say the reason that I'm a little nervous to use this one with a real student would be we have the class Charlie just above us, which is an airspace we wouldn't want to violate. We're also pretty near to Palo Alto Airport, so if we look on ForeFlight, we're going to be flying, 4 miles from the airport is pretty close to where we're going to have a lot of traffic converging. It seems a little reckless to go and fly the traffic pattern around, or to fly these maneuvers around here. But like I said, if the alternative would be flying kind of across the way, and I think to keep this to 2 hours, I don't think that's going to work. So, all right. Anyway, so you can see we have a nice kind of grid pattern here, though. So, ignoring the nearby airspaces, it looks real nice. So let's get ourselves situated here. And you see that I started going, kind of doing a cruise descent. So, I'm sorry, just a constant airspeed descent. So we're 2,000, let ourselves start to come down. And I want to get to 1,000 feet, so I'm a little low here. Okay, let me get this set up. So what I'm going to do, because we are just getting bounced around up here, and I think it's not going to be very helpful for seeing this. What I'm going to do instead is I'm going to actually put it to clear skies is fine, but what I want is another wind layer. And I want to put this wind layer where we're going to be flying, so at 1,000 feet. And this will be interesting to find out if they do true or magnetic here. I assume that it is magnetic. And so we can use the same 270 that we were looking at. Just want to make sure that that was... Yeah, so that's fine. So we can use the same 270 that we were originally planning on, just for this sort of demo. We don't need or really want gusts, but I do kind of want some actual significant wind. So I'm going to actually make this 20 knots here. And hopefully no gusts. Let's see if that all worked. Okay, so 270 at 20. I don't think we're going to get any mechanical turbulence from the hills over here. We'll see how this sim handles that, but I think we should be okay. All right, great. So I'm going to set up like this. Let's talk about the maneuvers themselves. Flipping back to the, actually, I can do it like this. Let me know if that's a little small for the maneuver. You know what, I'm gonna go like this just for now. And then we can flip to the other iPad in a moment. So first one we're gonna do is rectangular course. As with every maneuver, first thing we're gonna do is clearing turns. We're gonna ID our emergency field and then set our mixture rich, essentially establish or get ourselves set up for the maneuver. We want our altitude to be 1,000 feet AGL. So in the iPad, I have it set up to show me my height AGL. So we're at 872 right now. You can see in the bottom right corner. So I actually want to climb up about 130 feet to get to 1,000 feet AGL. These maneuvers by the textbook, you can do anywhere between 600 and 1,000 feet AGL. For the margin of safety for an emergency, it's really good to fly them at 1,000. The other thing is we're going to be over populated areas a lot of the time. And so we want to have a little bit more, you want to have a little bit more space above those populated areas. We actually should talk about the minimum altitude. Let me double check when in my syllabus I have that, but there's a minimum altitude you're allowed to legally fly. A really important first clause of that is that you have to fly at an altitude such that if you lost your power plant, if you lost your engine, you could land without undue hazard to people on the ground. And so that's where, like, sort of the trump all things is like 1,000 feet AGL. Like if you're flying at 600 feet AGL, you're pretty low to be able to do a safe emergency landing. Obviously, you can, if you needed to in an emergency, you do what you need to do. But if we're going to have the option to go either 600 feet above ground or 1,000 feet above ground, rather be flying 1,000 feet above ground. Okay, power. to enter the maneuver, so we're going to set power to 2,200. We'll select a suitable reference, and we'll talk about that in just a moment. I'll pop out to the sim and we can look at it. And then we're going to enter on the 45 to the downwind leg for left or right traffic. We'll use, how do we want to do this? I think the best thing to do would be to use a left 45, because that's typically your traffic pattern is left traffic. So let's practice that first. But in reality, you could enter on either left or right traffic. And so what that means is the downwind leg, the segment of land that's aligned with, or of the reference is aligned with the downwind, we're going to enter on the 45 to it here, and then turn downwind for our first part of the maneuver. We want to be about 1/4 to 1/2 mile from the reference, and we want to account for the wind, so that's where we get our crab angle on the base and crosswind. And then our criteria for success here is we want to have our altitude plus minus 100 and our airspeed plus minus 10. Okay, and the airspeed we want to be at is about 100 knots. That should be 2,200 RPM. A little bit more on this maneuver. This is to simulate flying the traffic pattern. We need to divide our attention between the air traffic control, airplane control, traffic, and ground references. You want to be aware of low altitude hazards like wires. One tip from the maneuver, I have a ground reference maneuvers booklet that I bought, which you should consider. Again, you always want to use resources that'll help you learn best. So if you are struggling with some of these, consider buying a reference. I have the Jeppesen one. I thought was pretty good. But one thing that they suggested is you kind of want to start turning as you cross this, the reference line. So right, you're flying 1/4 mile to 1/2 mile away from the reference line. And so you start your turn as you're crossing that reference line, right as you're a beam. So we'll do that. All right, let's flip back to the sim, and I will keep the Obsidian notebook up so that we can actually see this all laid out. So what we're using for our references are these salt flats, and specifically we're going to use this group of 4 right here, or group of 5, excuse me. So it's got a nice long straight legs here, straight legs here. These are pretty short. You know what, actually, let's use this full, these ones. So we'll use the big block off in the distance here. It's sort of like the right side will be this kind of white section. Then we'll use these, and that'll give us a nice kind of large rectangle we can work with. You want to enter on the downwind leg, the 45 degrees to the downwind leg. So one thing we need to determine is where the downwind leg is. We know the wind is coming from 270 relative to our airplane. So the wind is coming from our right tail. So if we pop out here, that means that wind is coming from this direction. And so our downwind leg would be that direction. So we are actually kind of aligned with our downwind leg now, so that works out pretty well. It also means that we won't be flying a perfect align to the downwind leg, since our actual downwind would be at about a 45 degree to this. I'm actually going to change the wind because we have the ability to do that, and it's really clean. In practice, though, when you're doing traffic patterns, it's unusual that you would have wind perfectly aligned with the downwind. So what you do is you crab into the wind just like normal. So it's not a big deal that the wind isn't quite aligned, but since we have the ability to change it, let's actually do that. So we want it to be instead more like 300 or so. So we'll give ourselves. All right, there we go. Great. Okay, so now our downwind is really clearly this leg here. So we're going to try and enter, we're going to enter on the 45 at 1,000 feet AGL, enter the downwind, turn around, turn around, turn around, turn around, fly this leg, and then depart off over here. Okay. Anything else to talk about with this maneuver? I think that's it. As with every maneuver, we want to do our steps at the beginning. So I'm going to make these big because this is sort of the reference for when you go out and fly it. This is, of course, a useful diagram to see. You want to be crabbing in and all that stuff, but this is sort of the quick memory thing. So I'll have this up. And let's go flying. So I'm a little low here. So let's go and address that. So 2,200 RPM. I need to climb up though, so I'm actually going to do a full climb and start getting up to my 1,000 AGL like I need to be. I'm going to do my 2 clearing turns to the right. So first thing I do when I turn, I look under my wing, make sure there's no traffic. Right rudder coordinated with right aileron as I turn. I'm doing a climbing turn to the right because I want to get back up to 1,000. And as I'm turning, I'm looking through my quadrants to make sure that there's no traffic. Okay, that is 90 degrees, so I'm going to level my wings, look around in my quadrants again checking for traffic, and look under my right ring, lift it up, and then turn to the right. Coordinated rudder and aileron, and we're flying like this. Now we're at 1,000 feet, which is great. I'm going to bring our power back to 2,200, so we start getting to our entry speed of 100 knots. And, okay, so again, through this entire clearing turn, we're looking for traffic. Climbed up a little bit there, so let me get my sight picture correctly set. Okay, good. And keeping in mind where my practice area is, or where my reference is going to be over there. So, okay, 2,200 is set on my RPM, and my airspeed is a little fast. That's because I'm descending quite a bit, actually. So let's get my attitude level here. Good. Okay, so we're flying a little high AGL. And so I'm going to go down to 900. Is that right? I wonder if that's a altimeter artifact, but we'll use our AGL that we see on the iPad. Yeah, that's still okay. The thought process I'm going through is like, I don't like that we're flying below 1,000. I'm seeing on the altimeter. However, we're still in our 600 to 1,000 area. We have good clearance. We have nice emergency fields, and so I think we're in okay shape to fly. Looks like 800 then to get our AGL correct. So I'm gonna fly at 800 for this maneuver. Got 2,200 set on my RPM, and I am now lined up for. I'm gonna go a little bit more to the right to get onto a 45 for this. So, oops, wasn't staying coordinated there. Okay, and turn back to here. Line up for the 45. We've done our clearing turns. Our emergency field we can talk about real quick. So let's get to here and let's look for an emergency field a bit. So outside of our window, these salt flats have wires that run along them. And so there's a couple of places where it would be really dangerous to land in an emergency because if you're caught wires that would be obviously problematic. If we needed to, though, these salt flats themselves, if they're dry, you can land on that and that would be okay. And that would be, I think, a nice emergency field like over here where there's no wires in the way and there's no wire on the final bit. And because our wind is aligned, we aligned the wind to these, but also because of the way we're flying, we would land into the wind to reduce our ground speed, and so we could land this direction pretty nicely. So if we have an emergency, we need to glide to somewhere, these look pretty good. You can actually see on the iPad, I have this, switch over to the iPad so you can see. This green line is a glide advisor that ForeFlight provides. So it's based on if you fly at the best glide speed and you lost power for where you are right now, that's where you could glide to. And so while we're doing these maneuvers, we have enough altitude to glide over to these ones. Since we're going to be doing the maneuvers here, and we have wires between where we're doing the maneuvers and where I'm talking about landing, I actually don't like that emergency field. More liking this one over here, or maybe even the kind of empty field out in the distance here. So, right, because if we have these wires here and we have to glide over and there's something comes up with the wires, that's really problematic. But if we were gliding over and we turn upwind from here, that would work pretty well, or maybe this field here is okay. So we have a couple of okay options. Landing on a road, because you may have wires along the road, could be pretty dangerous, so typically we want to land in an open field would be better. We could also land right on this, looks like a dry patch. The red, I happen to know, typically means that it's full of water, so it's shallow water, but I still don't really want to land, risk flipping or something like that. So I'll stick to the dry one. Okay, so we ID our emergency field, we have our mixture rich, and let's fly this maneuver. So, flying along, get to 2,200. And we're coming up to the edge of this, and I'm going to turn right to enter along for this maneuver. So you can see I've already lost some altitude, so there we go. And I'm looking out the window at my reference to make sure that I'm aligned with it, which I am not quite. Okay. And let's take a quick pause here. So one thing that I'm not liking about this already is my alignment's okay, so I want to be aligned with this. And we can look at this though and see that I am 500 feet from my reference, and I want to be a half mile like out here from my reference. So I am way closer than I should be. And that's going to be problematic because then as we try and do this turn, we're not going to have enough radius. We're going to end up turning to, and essentially finish our turn like right in here, as opposed to if we were doing it like this. Not only would we be able to see the reference clearer out our window, we'd actually be able to do this turn without as much problem. One other thing to keep in mind is these are not perfectly square along this end, so we're going to kind of extrapolate out this flat edge because we don't actually have it, and that's okay. So what I will do though coming out of this turn is I'm going to turn to a half-mile radius, so I'm going to fly a little bit beyond it, and then turn way out there. Okay, so let's get back in the airplane. Get our sight picture back. Okay. So I'm looking out my window for that reference. We are now abeam the reference point, and so I'm going to start my turn. Oops, I've lost quite a bit of altitude. And my power is not at 2,200. I'm not sure why that is. Maybe active pause. Again, I'm looking for my reference out my window. Staying coordinated. I was using too much left rudder. And, okay, there's the flat part of it that I wanted, so I'm still going like this. Okay. And let's make sure that we're at our right altitude. Okay, now we're abeam our next turn, and so we're going left again. Sorry, folks, I'm trying to display while also... Anyway, I wish I could rotate my head, I think is what I'm trying to say. But that's okay. We'll do the best we can. So we have... Good, we are at our correct altitude, correct power. And we can see now our reference line a lot more clearly at our window. We're more or less correctly spaced. The rule of thumb for traffic patterns and also for this maneuver, which is meant to simulate a traffic pattern, is you want that reference halfway up your strut. So this is a much better distance. So sure enough, if we pause, look at this, let's see, we are at, there we go, that's about a half mile. We're right on the edge of a half mile, so we could be a little bit closer, but that's pretty good. Okay, and I'm going to switch back from the iPad to the maneuver so you can see what we're trying to do. Okay, so back to my normal sight picture, and let's make sure we're descending. And again, I'm keeping an eye for my reference, because as soon as we get to the crosswind reference, this next turn, then we want to start turning. So, okay. Airspeed's looking good. Our spacing to this is good. We're abeam our next point, so I'm going to start turning here. Initiate the turn with a little bit of left rudder, and then once we establish the turn, I'll use less left rudder. Going in like this, watching for my reference point. There is not my reference point. This is the problem with Leslie Salt's, this area here. My reference is that. Okay, so now we are parallel to this. Now remember, when we are flying with a crosswind, we need to do our crabbing. So this is a good example for this one. In fact, let me do this. Yeah. Oh, that's so funny and so embarrassing. Okay, well, I will show this because it's a really good example of not doing it right. So if I go back to my iPad, actually I can go like this and just do the full screen version. So if you look, the green track is the track that I flew. This one, you can see the plane is right at the end of the track. And the reason that I'm laughing is that, remember we showed that oblong shape if you don't crab into the wind correctly? Well, there you go. So we're supposed to be doing this sort of, right, like this should be our base leg. And so we should expect to see this green line to be parallel to that right across, oops, like this. And I had forgotten to do my crab. And so sure enough, you can see that my ground track then is curved. Now I'm more correctly crabbing into the wind. So you notice the airplane is pointed to the right, or to the left, excuse me, a little bit to counteract our, oh, wait a minute. No, I'm pointing the wrong way because our wind is coming from our right. So I need to crab to the right more to make sure that I don't cut off this corner, which is already what's starting to happen here. Okay, well, sorry about that, but that is exactly why we crab instead of just flying it straight. So I'm going to come back to the sim. And we'll do it with the iPad so you can see. So now I'm correcting my crab here a little bit. Looking at my window for when I get, now I'm a little close. I can barely see the reference on my window. When I get to a beam it, which is here, I really don't know that I like these salt flats. So remember we're trying to turn around there, so I'm kind of got a far turn now here, but that's right. So looking out my window for when I'm a beam. Now we're going directly downwind. We shouldn't need any crab for it. And my distance to there is pretty far. So I don't really like that spacing. But that's all right. Okay, so 12:52. So we're definitely going to go past 1 to do these today. That's all right. So I'm going to go another lap around here. I've lost some altitude, so let me get back up to where I'm supposed to be. To do that without losing airspeed, I'll need a little bit more power. I'm going to power back to 2,200. And I'm continuing to turn through this to get to, oops. So there's my reference for the edge. And okay, so now my wind is coming from the left, and so I need to crab into the wind a little bit. So I'm going to turn a little bit further to the left even. Okay, and I want to be at 800. Okay, so now I may be crabbing a little bit too much in the left, but at least I'm accounting for the wind. And then as we come to the beam here, then we're going to start our turn. A little bit of left rudder. Turning through. Good, okay. And then this is directly upwind, and so we can just go straight parallel to this, and that's all right. Look out our window. It's about halfway out our strut. So that's all right. I'm like bouncing up and down here, and I'm not sure. I have a pretty consistent descent, which is not great. Okay, there we go. And then as we're turning, okay, so now we're a beam this one. So we're going to roll to the left. And again, for this turn, now we have a wind is going to be coming from our right side, and so we aren't going to turn 90 degrees. We're going to turn a little bit less than 90 degrees because we need to crab for this turn. So roll out a little bit short of 90 degrees so that we're crabbing to the right. And hopefully that gives us a nice perpendicular line here, or parallel line here. All right, now we are a beam our next turn. We're going to turn again. Now this time, because we were crabbed a little bit to the right, we're actually going to have to turn more than 90 degrees to get through the full turn. And again, I'm looking out here at my references to make sure when I'm parallel I roll out. Since we're going to go downwind, we don't need any crabbing. We just turn to parallel. And there's our reference again. Okay, good. So we're nice and parallel to it. Okay, and then this one, we only have the little bit of a corner to reference. It would be nice if it was a full square field instead. Once Once we're abeam, we'll turn left to back elevator so we don't lose altitude. Should be watching our references. Our wing kind of gets in the way, which is unfortunate. And one thing you can do too is you can use your compass headings to try and help with, like you can use your heading indicator if you bug up where the wind is. Okay, so now we roll out. Now we're crabbing a little bit into the wind to account for that. So you can see on my iPad, I'm not cutting that corner, or I'm not elongating out as much. It's a lot more parallel. Actually, I'm exactly where I was last time, which was a little bit angled too far to the right. Once we're abeam our next, and we again go like this. Oops, I lost some altitude. Okay, so hopefully that sort of makes sense. Sorry, it's a little bit clumsy, I think is maybe a fair word for it, but hopefully the idea makes sense. You can kind of see now on the iPad what this ground trek is starting to look like and more or less supposed to look like. So we have a square, square, square all the way around. You can tell that my first time around was real rough, but it goes from there. And then we exit on the downwind side, so we'd fly another 180 degrees. For time, because we have several more, or 2 more maneuvers yet to do, and I think it would be good to get through both of these today. Let's start talking about these maneuvers. And then, oops, that's not what I want to do. And then probably it'll take about maybe 30 more minutes to get through. So apologies for running a little long. I think sort of what we maybe anticipated for today's lesson. Okay. So let's do turns around a point first. The goal is to have a nice, clean semicircle here. And I'm actually going to turn my breadcrumbs to be a shorter time duration so that we can see them not, because I don't want to have all the breadcrumbs from forever on there. Oh, I can't even go longer or shorter. Ah, well, that's right. And what we're hoping to see then is that we get a nice clean circle accounting for the wind. So without wind, it's really easy. You just set your bank angle and you just kind of fly around the point and no big deal. When you have wind, you need to do this when you're going downwind. You have a steeper bank. When you have that tailwind, when you have a headwind, then you're using a shallower bank, right? So the faster ground speed, you need a faster rate of turn, so you need a steeper bank. The flip side, if you have a slower ground speed, you need a slower rate of turn, so a shallower bank. How we do this in practice is we're going to pick points along the circle to reference. So what I mean by that is it's really hard to know that you're keeping, right? So we want to be doing a half-mile distance. So let's say that we're using the center of this set of 4 we've been circling. We want to keep a half-mile distance from the center for this maneuver. And so that's actually just about where our circle is here. I kind of wish I was, let me see if I can clear these. Nope. All right, that's fine. I was going to try and clear the breadcrumbs so that we could see it more cleanly as we're doing it, but this will work. Okay, so why don't we do... Yeah, that's okay. Okay, so we'll pick a point. Typically an intersection of roads works really well. We have the salt flats work pretty well. What I was just thinking is we could actually go to a different place to do this. The reason that an intersection of road works really well is you want to pick points that are along the whole circle that you're going to be flying. So for instance, let's say that you pick, let's go, well, so we'll go out here where that Meadowlark field is, that nice kind of practice area. So let's say that you say, I'm going to use this intersection here, and I'm going to have my legs be 1/2 mile in distance. So that's about a 1/2 mile. That's pretty good. And so you're going to have from the air picked out this intersection, this intersection, this intersection, and this intersection. And then when you go to fly that, all you really need to do is fly from one intersection to the next intersection, to the next intersection, to the next intersection. And so you should understand that you need a steeper bank as you're going downwind because you want to anticipate that. But in practice, you just can fly between those points you've picked out. So whatever bank angle you need to get to that point is the right bank angle to use. Again, anticipate that when you're going downwind, faster ground speed, steeper bank angle. But by picking out those 4 points, you make your life a lot easier. So as you can see on a grid pattern where you have either roads in a grid or fields like this, it's really kind of nice. Where we are, we can use the Leslie salts, but it sort of gets tricky because, you know, like this spacing is pretty good. That's a little far still. I don't super love any of these for this. Let's actually just teleport out here because I think this is worthwhile, and also trying to do it with the Leslie salts is just going to be more and more confusing. So I'm going to go to the main menu. Show you what I'm doing here, I suppose. World map. And let's see if we can get... Oops. Look at that. They do have it. Okay, great. So we'll do this. Set as departure. We can even just get in the air a little bit. So here we are, Meadowlark Field, and that'll be really good. Okay. So sort of drew roughly what the circle I'm looking for is. Because we have a nice grid pattern here, there's a lot of good options that we have. I will probably use this one because there is some airspace concerns over here. You can't get below 800 AGL, and if we were flying maneuvers over this is where a research laboratory is. If we were flying 800 or maneuvers at 1,000 feet over that, they would get pretty nervous, as would I, taking a student over there. So, all right, let's get set back up here. Oops, I forgot we have live weather, so let's fix that. So I'm going to go back to new wind layer at 1,000 feet where we're flying, and let's have some wind from 270. That's still good. And we can turn our gusts. So we'll make our wind 20 knots, so we have actually quite a bit of wind to be working with. A gust per minute. So this is sort of an extreme example of what these look like, but hopefully that's useful to see. Normally you'd have way less wind for this stage of training, but also yeah, it'd just be way less wind, which makes all of the corrections smaller. It's kind of nice to see them with a little bit of exaggeration. But okay, so we're now kind of paused over Meadowlark. We do our normal clearing turns, so we'll do 2 90-degree turns. We're going to pretend we've already done that for time here. I'm going to hop out of the plane so you can see our nice emergency field. There you go. We actually have a... Oh, they also have a Star Wars symbol on the ground here, which I think is pretty fun. But they have a nice runway here. If we had an emergency, we could land there. And then I'm going to use the intersection just before this riverway. So we're going to use this intersection as our intersection. Wind is coming from 270. And so we want to enter on the downwind, which is our steepest bank. And so 270 for us right now is here. So our downwind direction would be coming this way. So we're actually going to fly. We can cut across maybe, and then we'll come back around and enter this way. So my throttle's really low. Okay. Anything else to point out? Emergency field mixture rich is already rich. Power 1,000 feet AGL and power 2,200. So let's start flying here. 2,200. Anytime before we turn, look under our wing, check for traffic. Okay, turn to the right, or to the left, excuse me. Oh, haha, there's my autopilot. Okay. And we are at 1,200 AGL. So we're going to use 1,700 here for our maneuvering altitude. That'll get us to 1,000 feet AGL. Oh, actually 1,900. There's a little bit of hills. Okay, let's do 1,900 then. That's fine. So 2,200. Again, always looking for traffic. Our intersection we're going to use is the one just behind the strut there where those trees are. That kind of 3-part intersection. And so then our one of our intersection points is that one off to the left here. 1,000. What is it? Okay, we'll use 1,700 seems to be the more consistent number. I'm expecting to see... Anyway, this is okay. So I'm going to turn back around here. Yeah. Sorry about that. One of the things that, because I use my spacebar to jump up and down, the Bravo, the Honeycomb Bravo throttle quadrant is in my thumb path to go and press the spacebar, so I keep hitting my RPM, which you would set it for this maneuver. You would never want to be just changing all the time. But that's okay. So let's look down. We'll make sure that we have our field that we're gonna, our center point in sight. We're coming around to our... Okay, so where is the point that we're looking for? Okay, so there's our intersection. 1,700. We're entering on the downwind. Oops, sorry. Okay, so let's look real quick on the iPad. So our distance here between where we are and the field is about 4,000 feet. So we're a little wide on where we should be. And our first intersection point we wanted to use is off to our left here. So it's actually this road right here. So we're a little bit to the left of where we want to be. The cleaner we can get those points and the cleaner we can get to those points, the better off we're going to be. So again, to remind what those points are, there's this one here. There's, so now here we can actually see them. This guy right at the corner of the golf course. There is this guy right. Is that right? Yeah, this guy right here, which is on the other side of Meadowlark Field, and then there's. Make sure I got this one right. This guy right here. So, 1, 2, 3. Looking at the right thing here. Yeah. 4 intersections. We're going to use this one. So we are currently misaligned with this intersection. I'm actually going to turn around to the right and get back aligned with that intersection so that we're kind of set up correctly. We are currently going downwind, so in that respect, we're entering on the correct leg, but we're a little bit too far to the right. It's going to set us up for rough entry here, so no reason to go in incorrectly there. This RPM really likes to climb. Okay, 1,700. And again, every time we turn, we want to be looking under our wings. Oh, scanning for traffic. Okay. I love climbing over these fields at such low altitude. The other thing for all these ground reference maneuvers, we always want to be aware of where things like power lines are. So we have a row of power lines that go here. They're low enough that we are able to do our maneuvers over them, but we definitely need to know, especially if we did have an emergency, we needed to land, we want to know where those all are. A little bit more airspeed than we want. Keeping my intersection in mind of where I want to get to. Okay. Right. Angling myself back here. I think I want to be turning steeply here. Okay, great. The 2,200. We got a doggo that's concerned about something going on outside. I don't know exactly what, but... Okay. And I'm going to roll out of my turn here. 2,200. Done our clearing turns. We have our field ID'd. Also a little bit of altitude. We want to be at 1,700. So let's get back up there. And... Okay. And our first point is straight ahead here. And remember, our next point is the corner of the golf course there. Let's keep losing some altitude here. So now we're going downwind. We're going to want our steepest bank. So as we cross our line there, we roll into our steep bank turn, and really what we're doing is trying to fly that nice radius turn, and to do that we're just going to fly as needed to get to that next corner, which is the corner of the golf course there. So okay, good. So now as we come towards a headwind, we're using less and less bank because we need less and less rate of turn. So our next intersection is the one just at the corner where the corner of Meadowlark. So you can't really, oh, my picture is all wrong. There we go. So you can see now we're just coming up to that. And I'm using a pretty shallow bank at this point because we're going, we have a headwind. We just lost a little bit of altitude. So remember our thresholds are plus or minus 1,000 feet altitude. So that would have been not acceptable for the final test. Okay, and then we're crossing our next point, and now at this point we're basically a very, very shallow turn, but as we get to an increasing tailwind, we're going to be increasing more and more bank. I've lost more altitude than I should have through that, so I'm going to angle up just a little bit here, still watching my airspeed, and I'm looking at my next intersection, which is, remember, increasing bank as we go to fly to the next intersection, and that is this road sort of right here, just out our window. Good. Okay, and then now we're going into oh wow, I've lost a lot of altitude. This is the dividing attention between inside the plane and outside. So our next intersection is right there. As we're going into our downwind, we need to be using the most amount of bank, so this is our steepest bank. And there's our intersection. We're flying over. As we start to leave our downwind, then we use less bank. So increasingly shallow until we get to, again, flying to that next point at the corner of the golf course there. Okay, good. And increasingly shallow banks. I kind of removed my bank a little quickly there. I should have kept it. Also now 300 feet down AGL, which in a real maneuver isn't, I mean, it's not acceptable to go below 100 feet, but if a student started to drop that much, then we would focus on resetting the altitude. So I should actually just be doing that. I think that's good. Okay, so the next one, again, now we're going upwind, or so we have a headwind, and so we're going to have our shallowest bank, again, coming to this point. And as we're coming to here, I'm looking for the next point I'm going to be going to. I can kind of see it just before that house out there. So now I'm starting to bank for that. Again, losing a lot of altitude, and I don't know if that's something I'm doing or if I'm not maybe properly trimmed. At any rate, so okay, so then to this one and on and on. So the idea you can kind of see on the iPad is you should get these really clean equidistant circles. So I already drew what the circle I wanted it to look like, and you can see my flight track, because I'm flying between all these points, starts to look like a really nice kind of clean circle. And to do that, of course, I'm increasing bank and decreasing bank. So you saw that I needed a lot of bank when I was downwind and very little bank when I was upwind. So hopefully that was pretty clear. The next thing I want to do here is actually S-turns. And typically we enter S-turns by redoing the maneuver setup. So we'll do a clearing turns, ID emergency field, the whole bit. We have kind of a nice road we can use here. In the real world, I would be hesitant to go this way because, like I said, we don't want to be doing maneuvers over this restricted area. So flying a maneuver that would take us in that direction is a pretty bold choice. Because we're in the sim, I feel okay doing it, so we're going to use that for a nice reference, but just to be very, very aware that this is not an okay place to be flying this low otherwise. Okay, so the way that we do S-turns, same sort of idea as the turns around a point. We're using steepest bank when we're flying downwind, shallower bank when we're flying upwind. You're going to do the same basic thing that we did with the S-turns in choosing 5 points along the way. So let's look at our map here. And by the way, I'm choosing these beforehand to show you what I'm going to be looking for. What you would do in the plane, though, is you would, as you're coming towards the area you want to do your maneuver, be looking for what those points are. And in a lot of ways, you're choosing what you're going to use for your reference point so that you have nice points around it that you can use for reference. Okay, so if I go ahead and let's clear this one. So the S-turns are going to be equal radius things again, and so we're going to enter on the downwind like this. So we can use these two as our first, right? So we can use the same basic first couple points. So we'll do a circle like this, and then the second half here. For our second half of our S-turn, we want another equidistant one. And so we can use maybe this road here, just at the edge of this green pasture. And the next one can be the other side of the road there. Oops. Come on. Okay. So then our S-turn is going to look something like, oh, sorry, we needed another point that would be a half-mile radius out, so we can use the intersection where all the laboratories are here. Again, not great as a point in the real world, but okay for this. It should be equidistant, so we want all these radius to be the same. And so about a half-mile radius is good. Okay, so this is okay. So we'll use the edge point of here. So it'll be like this intersection. And so we'll go out like that and then back. And so then the plan is when we go through this whole thing, we should see this one. We should see this nice S-shaped turn, just like we have here, right? Downwind steepest, shallowest here. The other thing to be aware of as you're flying this maneuver, you want to make sure your wings are level as you cross your reference line. So if you're doing this correctly, it should be steepest bank, moderate bank, shallowest bank, wings level, shallowest bank, moderate bank, steepest bank. This is extra important for your check ride because one of the easiest things to tell if the student is doing it correctly is if their wings are level by the time they cross that reference point. So I'll kind of show you what that looks like when we go and fly it real quick. But that's our rough plan. So, okay, let's go in the plane. So make sure there's nothing else. This would be the reference you'd have. Same sort of power and setup. Again, tailwind, steeper bank, headwind, shallower bank, and then choose the 5 points. Altitude plus minus 1,000, airspeed plus minus 10. Okay, so not on the right window. There we go. So I'm going to climb back up to our correct heading, or to our correct altitude. Make sure I'm still turning to get to our entry point. So we know that we're going to use that same road that we were using sort of as our base reference before. 100 knots. We're going to be 100 knots, 2,200 RPM. A little bit lower than this. There's that road. And so this was a really bad setup. Let's redo that. And for the sake of time, I'm just going to zip myself backwards. The reason I didn't like that setup is I don't want to be coming into this maneuver at a bank like that. So instead, it'd probably be something like this. So we have already set up our maneuver speed. We're at the correct altitude. I'd like to be a little bit higher still. Okay, there we go. 2,200, 100 knots, and we're coming up right to the intersection that we want to be starting at wings level. So come on, RPM. There we go. All right. We'll use 1,600. Wish I could get this a little more. Okay, so as we cross this line, we start our turn. Steepest bank at the first point here. Same thing as turns around a point, so we're using those reference points we've picked out and basically flying to those reference points. So I'm watching my altitude, dividing my attention between that. Also traffic, keeping an eye out for any traffic around. Lost a little bit of altitude, so I'll keep climbing. And this is my steepest bank. As we start to head upwind, then I'm going to use a shallower and shallower bank. And I'm keeping my next point along this in mind, which is going to be that intersection right there. So again, you see me slowly shallowing this bank as we go, because we want to be at wings level as we cross this road. So coming through here, oops, lost quite a bit of altitude there. And as we're coming to, now we're pretty shallow, and then as we cross the road, wings level should be perfectly perpendicular. Okay, oops. And then as soon as we cross the road, we want to roll to the right, and again, it's going to be a shallow bank to start because we're going upwind. We're looking for our next waypoint, which we'd picked out, and so we'll use this thing off in the distance, that intersection of roads. Again, real shallow here. I've lost a bit of altitude, so I'm adding some power to make sure that I can climb back up. Okay, and my intersection's here. Now, as we turn more downwind, then we're going to be needing increasing bank. So you can see that I'm increasing my bank, staying coordinated. Looking for my next point now off and to the right, which is the intersection of these roads. Okay. Oops. More and more bank as we're going here. As we get downwind, then we need more bank. Okay, and I did not get to the point that I was meaning to get to, which was a little bit before here. But this would be the steepest point of the turn, and then wings level as you cross the intersection. So, all right, and then we could keep doing that if we wanted to. As soon as you cross the intersection, you roll in, again, steepest bank here, keep going around. And we'd pick out our next point that would be about, half mile out, so maybe that's like this one, and we can keep going from there. That was a pretty, I would say, lackluster presentation on that. So let me highlight some of the things that went well and some things that went poorly. So I'm looking at my ground trek, and you can see the one that I just flew here, like that, and you can see this one. So something that I think went well is that this first curve was really nice and really clean. Of course, I'd done it a couple of times, so I sort of already had a good sense of what it was going to look like. I wanted this curve to be a little bit tighter, and I think as I started to come out of this, I didn't increase my bank enough to increase my rate of turn, which meant that I wasn't getting this kind of nice radius that I wanted. And so instead I ended up doing this kind of oblong shape. Not for nothing, that is the exact same shape that they show as the doing it wrong shape. So not a great feeling from my perspective, but point out where things go poorly as well as where things go right. So I think what I needed to do then for the second turn was to increase my bank sooner to make sure that I'm getting that correct rate so that I line up with where my next point is. I also don't necessarily think this is a great half circle, so maybe my point selection was off a little bit too, but there we go for that. So let's do one more turnaround a point. And what I want to do here differently is I'm actually going to fly it from this perspective and see if I can get, I want to do that perspective. So this is how I think it looks most realistic. So let's, I'm sorry, I didn't show you that change. So normally I have it way far back so you can see all my controls. I'm just going to see it like this so that the Earth doesn't move quite so fast and I can actually see my points out the window. And let's see if we can do a little bit better on that one. So first of all, I'm really low. I'm at 600 AGL, so this is lower than it should be. We also are crossing over that laboratory, which we don't want to be doing. So let's do this from scratch. So I'm going to start climbing here. So I have full throttle. My pitch attitude is for a cruise climb, so I want to get to about 90 knots. And remember, the sight picture looks a little different because I've changed my camera. So normally I have it set like this when we're flying, so you can see all the controls. I'm going to set it back to here, which I think looks a little more natural. There's 1,700. Bring the power to 2,200. Let's get to our correct altitude, correct speed. We'll get our reference up so we can see how we want to fly this. So we know that the wind's coming from the west, so that's sort of from this direction. So I'm looking for a point that's going to be a good north-south line so that I can enter crossing perpendicular to the west. In this particular airspace, we actually have quite a few airspace concerns. One of them is the class Delta here. So if we were going to be flying where we are now, we need to be talking to that tower. I'm going to use, off to the right here, there's a road that I kind of like. I don't like that it goes into the hills. Okay, yeah, I think we can use this one. So what I'm going to do is do kind of a wide turn around and see if we can get lined up nicely for that. Let's do it like this. Oops. Why is it doing that? Sorry, trying to get my view back. Oh, there we go. Great. Okay. Again, before we turn, we always want to lift our wing and look. And the road I want to use is actually behind us, so I can't really see it anyway. Yeah, I think the thing to do... Actually, I'd be really open to feedback for folks tuning in if this is useful. So what I have been doing is kind of trying to show the whole cabin so you could see like if I have flaps down and all that sort of stuff. The problem is that for me flying, everything feels really weird. And none of my sight pictures are the same, and so I keep feeling like I'm really kind of botching a lot of the maneuvers. So like this is how I normally fly if I'm actually practicing sim flight, because this is a lot closer to what I'm seeing in the aircraft. And I'm realizing that all I would really be losing on that perspective is the throttle and the flaps. And I think both of those two, you can read the throttle on the RPM anyway, so that's okay. And the flaps I can call out. And of course, you know, flying without a CFI, that's something you need to be reminding yourself anyway, so it's sort of tricky regardless. Anyway, I'm going to try flying it like this just to see if I like this more, and perhaps in future lessons this is what I'll use. So, at 1,700, this 180 degree turns we've done here, we can treat as our clearing turn, make ourselves visible. Also, we'll be looking for traffic. So, there we go. And I'm going to use this road just off to our left. You can't quite see it, but it's like coming right off this highway intersection here as our reference point. I lost a little bit of altitude, so let's get back to where I need to be. Okay, so it's the one that comes off of that clover leaf right there. Okay. So I should be trimmed up before I do this, so we're going to start at 1,600. And then as we cross this intersection, we're going to roll to the left, and I'm looking for the next point that I want to use for my 180. It's better to pick them out sooner, because you don't want to be just like on a whim deciding what you're going to use for these. But so I'm going to use the intersection of the highway down here. So we're kind of flying to it right now. Remember, at this point, I'm at my steepest bank. Okay, and then my radius to the... Oops, that's not going to work. My radius to the road is about a half mile, so that looks good. Okay, looking out my left window. And then, again, oops. So I should have a bank through this entire thing. Increasingly shallowing that bank as we go, and we're going to use the intersection just on the other side of that building looking thing. As I'm going upwind, I'm shallowing my bank. Lost some altitude here. Correcting back for my altitude. Okay, and now we're at our shallowest bank as we're going upwind. Again, we want to be choosing our next point that we're going to be using. Wish I could see a little better out the side, but we'll use maybe that building on the hill there. Tricky part about using something on a hill is all these references are supposed to be above AGL. So, you know, then all of a sudden you're kind of changing perspective on where you're going, but that should be all right for what we're doing. So shallowest bank at this point in the maneuver. Trying to fly over to here. Again, I'm losing altitude here, and I think a little bit of it is not applying enough back elevator pressure. Now, as we start to come through this part of it, increasing our bank, we're going to need more and more as we move to the downwind part. And our last reference point we want to have intersect with our reference road will be kind of right off in the distance here where that home is. So increasingly steep bank, watching my altitude. Actually, I think my road is this road, so we'll use kind of this faux extended intersection here. Okay, so still lost some altitude, not super pleased with that. But as we come through steepest downwind and as we cross our road, we want to roll this level. Okay, so this sight picture is not what I'm looking for, in that my wing angle to the road is like I'm off. So when I'm at wings level, I should have been perpendicular to this road, this reference point we had. I didn't realize that I was going to be off the end of it when I did this, so that was a poor choice of reference. But there were some things that I liked about it. The actual semicircles themselves look pretty clean. So the so I can turn off Quiet Advisor. So these semicircles here look relatively clean. I was wings level as I came into here, which is really good. So perpendicular road is that. This semicircle then looks clean. You don't see that sort of drift correction issue that we were having before. I didn't do a great job of picking out this point before I got there. I think, one thing that would have been better is if I had picked a reference that went longer and I could actually have chosen something along that reference. But the other thing that would have helped then is I would have known exactly when to be wings level. You can actually see that I continued the turn too long, and that's why I wasn't wing level as I got there. And so if I instead had been looking at my window, noticed the reference point correctly, and rolled to wings level, it would have been really nice to finish. But overall, it's a rough S shape. It doesn't show much of the wing drift kind of issue that we're really trying to build a muscle on here. So, also shoots, thank you. I think that is exactly the right philosophy on this, and I think what I might actually do for tomorrow, assuming I can get it working, is set up the VR headset, because I think one of the other things that's really difficult to show and to do correctly with this is where you're looking and how I'm making those decisions. So especially when we talk about when to start your turn for base, final, that sort of thing, I think having that VR headset may really help. I'll have to figure out how exactly to stream that correctly, and it may really bog down the computer's performance, but I think it's a worthwhile addition. So we'll give that a go, and yeah, maybe, I mean, that might be wonderful. That's one of my preferred way to actually practice in the sim, is to use the VR headset. I think that works, especially for maneuvers like this. It's really nice to kind of get a feel for it. All right, let's close the lesson out real quick. A little bit over time for the normal length, but we sort of expected that. A couple common errors: forgetting to check for traffic or locate emergency field. Failure to divide attention between aircraft control, instrument check, ground references, traffic, and situational awareness. So a couple of these that I really got myself bit on today. Ground references, when I didn't roll out in time at the end, classic example of that. Aircraft control, you saw me losing altitude throughout maneuvers. So that's another one of like, you need to be flying the attitude that you're seeing out the window, but then cross-checking the instruments. And so making sure that we're doing that. Improper correction for wind drift. Lack of rudder coordination. So this is especially as we're entering turns, you need to use your rudder as you're going, as you initiate the turn. Failure to maintain altitude or airspeed throughout the maneuver. Airspeed I think was all right, at least as far as I was seeing. Altitude though was a little bit rougher. All right. Completion standards. Client must demonstrate the ability to choose a appropriate location, select a safe entry speed, and perform the maneuvers to ACS standards. Tolerances are 100 feet plus or minus knots. Required homework. No required homework. Recommended homework. Oh, this should have chair fly. So these are great maneuvers to chair fly and kind of think through what you're looking for and what you'd be picking out. So that would be my recommended homework on these ones. I think that's it for today. Any other questions before we close out? All right, well, if anything comes up, always feel free to post in Discord, or if you're watching this on YouTube after the fact, always feel free to message in there. And I will see you all tomorrow for flying the traffic pattern. All right, have a good Monday.